Hello world, it's Siraj, and let's build a decentralized Uber. So this is a peer-to-peer ride-sharing app. What you're seeing behind me is the decentralized Uber. Well, one of them, it's called Arcade City. And basically it connects riders and drivers together without a third party in the middle. And people can use their internal token called ARC for Arcade City. It's short for arcade. And this is an app that's actually in use by real people. Real people are taking rides using this app. I know, what the hell? Uber better watch out. So in this video, I'm going to teach you how these decentralized ride-sharing apps work. We're going to look at some examples that exist today. And at the end, we're going to build a very simple smart contract to allow for people to rent an autonomous car. That is a self-driving car. And all of it's using smart contracts, Solidity specifically on the Ethereum blockchain. We'll get to all of that in the end. But I just wanted to start off by showing you an actual demo video of an actual app. You can go out, you can download this app, it works. And yeah, so that was just a demo app. But let's get to the good stuff. So Uber, right? Uber is the biggest logistics and transportation company in the world right now, and it's growing very fast. Let's look at some numbers here. Uber's got 8 million drivers on board. 160,000 rides are currently happening worldwide. 400 countries, over 400 cities in 70 countries. They've completed over 1 billion trips, 1B, billion trips in that time period. And that's insane. And good job, Uber, and good job, Travis Kalanick, for growing that thing. But we have some problems here. So Uber's valued at $66 billion. And so Uber drivers, if you've ever driven for Uber or Lyft or any of the other, really, this applies to any of the ride-sharing apps out there, the drivers generally complain after a while at the gap between the fare that a rider pays and what the driver actually receives. You know, that cut in the middle, that middleman cut gets bigger and bigger and bigger over time, right? So Uber had an official statement about this, and they said they're charging some passengers more because they need the extra cash. Okay, that means they're using machine learning techniques to estimate how much groups of customers are willing to shell out and then charging them that much. So those are two separate problems. The first problem is that drivers are not being paid enough for what they deserve to be paid. Second of all, they're charging certain users more than they should be getting charged just because it's a proprietary algorithm and because they can. This is not good. Someone traveling from a wealthy neighborhood to another one, they can use machine learning and inference techniques to say, well, the likelihood that this person can pay more is higher than X, you know, some threshold, let's charge them even more. And the promise that if you see any of these billboards for Uber or Lyft, be your own boss, it's not really true because real entrepreneurs are free to compete in an open marketplace where they can set their own pricing and terms of that transaction. Drivers cannot do that in Uber. And this centralization makes Uber vulnerable to regulatory actions. And there's a possibility they can be shut down by governments. And this has happened. This is not just a theoretical thing. Actual governments have stopped Uber in Paris, in Austin, Texas, in several cities across the world. China, all of China, for example. Uber cannot operate there. Well, they can, but they're competing with an incumbent, which is just beating them. But anyway, so what's the solution here? Of course, decentralized applications, right? So to refresh us on this topic, all the applications we use from Facebook to Twitter, they are all centralized. It runs on a server or a server farm. There's a single point of failure there, and it is very fragile as an app. But a decentralized app runs on many servers. The nodes in the network, that is the users, share the authority of the creators as well. And there's no single point of failure. You take down one node, it's okay. The rest of the network will still run, and it's more resilient. And what we are experiencing now, I don't know if you've been watching this Zuckerberg testimony live. I was just watching that. It's pretty hilarious stuff, right? Oh man, he is really under fire. It's kind of fun to see how uncomfortable he gets. But yeah, there's a radical change underway. You are experiencing it right now. And one where a real peer-to-peer exchange where the crowd replaces the corporation as the center of the market. And that market could be for ride sharing. It could be for home sharing. It could be for sharing anything. It could be for sharing, you know, your pictures on a social network, whatever it is. The crowd is replacing the corporation. And the blockchain is really incentivizing all of this. It's really the catalyst to make all of this happen. Right? So what we need is an alternative ride-sharing business model. That's what it really comes down to. What kind of new business model can blockchains offer us that traditional server-based architectures cannot? And that's what I'm going to show you in this video. So check this out. An owner purchases a self-driving car A, registers it on a shared ledger, and sets the data sharing rules, right? So that's number one. While it's parked, it's placed on a register of available vehicles. Another person wishes to use the car. They consult the register. They make a payment to the car. The transaction is added to the ledger, et cetera, et cetera. And notice there's just a ledger involved here, right? This is an autonomous ledger, a blockchain, not controlled by any third party. So this transaction between user A, user B, and car A is happening all in this database that's not controlled by anybody. So could we set up a new company to do this? Like, how would this work as it gets bigger? What would happen here? Well, ideally, here's what would happen is we would have a new kind of company that gives people working on that platform not just payment, but ownership, equity, shares as well. That's much more of an incentive, right? If I've got Uber to offer you, if you're a driver, right? And I'm Uber. I'm like, hey, I'll offer you X amount. And now I'm Mr. Decentralized competitor to Uber. And I'm like, hey, I'll offer you even more. And I'll offer you shares in the network. Who are you going to go for? Right? This is a no-brainer solution for developers looking to build the next wave of applications. Not only can you offer them more money, you can give them shares in the network. And of course, they're going to convert to your alternative. And as this company gets bigger, the people working with them will also get richer. So everybody is sharing in the profits from this company, and they are all incentivized to grow the company through word of mouth, etc. So users should be able to decide by consensus in real time on the most important decisions pertaining to the platform, right? So it's not just the people behind the Uber firewall or closed wall, whatever you want to call it, that are making the important decisions. It's the riders and the drivers. Everybody gets a say in how this network works. And that's just a more democratic model. And we're going to shift the decision-making power to the drivers with respect to the pricing. So drivers can decide how much they want to price their rides, how valuable their time in their car is. And lastly, what works well as a business model in London may not work as well in Mumbai. And what we can do is we can decouple this from being a single global legal entity to being a network that has disparate smaller legal entities. And we'll talk about that. So you might be asking, okay, so what's the solution here? Blockchain? The answer is yes, partially. So this is a cool graph of all of the different features that different types of ride sharing services offer. And notice how the one on the far right, BitCab, is one example, but it offers all of these things in a way that Uber cannot. So if you want to make any kind of slideshow to show investors, definitely take a play out of this book. But just one thing to remember is that building applications on the blockchain offers three properties, right? Immutability, so no one can change the code once it's been written to the blockchain. Persistence, so everybody that has a copy, so you can't lose that data. And trustlessness, so you don't need to have a third party. Well, it turns out that there are a lot of edge cases in Uber that don't really need a blockchain. Like if you get charged for a ride, but never get picked up, you wouldn't want a transaction like that to be permanent, right? You would want that to be mutable. And so you wouldn't put everything on a blockchain. A blockchain can take so much, right? But it's got to be for use cases that obey these three different criteria: immutability, persistence, and trustlessness. And everything else we can put on a decentralized data store like IPFS. I've talked about this in length. Search IPFS Siraj on YouTube to get links to that. But all of the consensus can happen on the blockchain. So TLDR, drivers could earn equity, set their own rates, negotiate and transact directly with others, and build direct relationships with riders for a stable and recurring customer base. And lastly, self-organize into pods or co-ops and partner with other businesses. When they say that if you are going to build a startup, have it be 10x better than the competition, this is what they're talking about. This is a 10x better idea. Of course, riders and drivers are going to go over to your app Well, mostly drivers, but that's all you really need, right? At first. So definitely build something like this if you're thinking about what kind of application to build. So let's look at some of the examples. I've only got two that I could find that are, kind of in the works and, being done. One is called SnagRide, and I really like their, little tagline here, AI plus blockchain plus ride sharing equals SnagRide. So they know how to capture my heart at least, but they're using smart contracts for the drivers posting their destination and departure detail, basically their information, right? So all of this is happening on the blockchain. And the smart contracts contain all the information for the users, the name, the age, the location, the price of the ride. The data is encrypted on the Ethereum blockchain. And once a driver confirms a ride, a new transaction is initiated that will broadcast the confirmation and the driver information to the Ethereum blockchain. So all of this is happening on the blockchain, and what they have is a proprietary intelligent smart contract, which keeps that intelligence, that routing, how these people are actually matched, it keeps that hidden. And is that a good thing? Maybe, maybe not necessarily. If you could figure out a business model where this is not proprietary, that would be ideal. You get more users because there's more transparency. These are features that users of the future are going to look at. How transparent is your business? How equitable is your business? Is it fair? Are they able to make decisions? Do they have agency? These are the kind of features that users of the future are going to look for. And what they offer is a token, their own token. It's called Mile. It's used to pay drivers and riders and allows their AI to match them both. So they had a token sale at the beginning, right? And this token acts as both equity in the network and as a currency. Should you use a new token? Maybe. You could use a new token to give equity. You'd have to register that with the SEC or wherever you're based. And then you could use actual currency like USD or, what have you, pounds, euros, to then pay people. So it could be both, right? It doesn't have to be both at the same time as one. So another example is Arcade City. This is the demo that I gave at the beginning. But when it comes to Arcade City, this was really cool. So it started when Uber was made illegal in Portsmouth, New Hampshire. A couple of drivers banded together and started what they called Arcade City, a peer-to-peer ride-sharing service. And they used at first a Facebook group to coordinate all of these rides. But later they built an Ethereum-based mobile app to do this as well. And it's very cool. They had their own currency as well. You acquire it, you use it to operate the system, right? You have some internal token. It's used to access some scarce resource in your network. In this case, that scarce resource would be rides. And so because these are scarce, these tokens appreciate over time in value. And you can spend these tokens in real life through an exchange, etc. So that was another way of doing this. And there's so much potential for this, right? Don't think of it as like, well, it's been done, it's over. No, there's so much potential here. So let's look at a smart contract example. What we're going to do is we're going to look at an example where we have an autonomous car. This is a self-driving car whose ownership is shared by several people. It's available for anyone to rent out for the day. And once that rental period is over, the earnings will distribute to all of its owners. If it's 3, boom, right? And all of this is going to happen using smart contracts. So I'm going to make 3 assumptions here. So the first is that the car is running a full node, a full Ethereum node that allows it to sign transactions. And we'll pay no attention to any kind of side cases as well, because that's out of the scope for this very small demo. And the users have a device capable of interacting with the blockchain, like a Web3 enabled browser or a phone, for example. So the first thing I'll do is I'll create the address of the car. So the address of the car is going to be called car signer. And this is the amount that represents the car. Okay. So, as I mentioned before, the car is supposed to be running on its own node. So which it's going to sign transactions, and this account, will deploy the contract for the node and the account. And we could assume that neither the dealership, nor the manufacturer has the access to the private keys of this account. So the next variable I'll write is the car value. This is the value of the car in Way, like the Ethereum currency. And these are values that should be provided when the car contract is deployed, right? So license plate could be, I'll have another one called license plate, which could be it could be used to identify the car, right? So We're not making any checks to make sure it's unique though. And the car value sets the price the owners paid for it. We're not using car value, but we could have a function that allows an owner to sell his share of the car to someone else. And car values owners could be used to establish a base price. Well, the other thing we'll have is an array of all the owners. So these are the owners of the car, and they'll be the ones that receive payments for the car. We assume that each owner owns the car equally. So we'll say, well, there's going to be about 100, there'll be 100 owners in this contract. And then we'll need to distribute the earnings between everybody. So we'll say, we'll create a mapping where we'll say the mapping is going to be for the owner's balance. And when the car starts a paid ride, it will store the ether received in its own balance. And then when the ride ends, it will be distributed to each owner in equal parts for the owner to manually withdraw his balance. So I'll say to distribute, and then one for the initial car shares equals 100. Okay, so then again, we need to have some kind of variable to store how much of the car each owner has, right? So for the time being, we made it so that each owner owns equal parts of the car. So we'll say it's going to be an integer, unsigned integer. We'll call it public car shares, but it could also be done so that someone could own 50% of the car, someone could own 10%, someone could own 30%, but we're just going to have it, done this way because it's easier for now. We'll have some more variables called driver entity, drive status. These variables are a part of a state machine that will control what the car is currently doing, right? So who is driving the car? Are they driving the car this way, this way? What are the different ways that they could be driving the car? So we'll have that as well. And three more, and then we're good with these variables. One more, we'll have an address for the current driver, like who is currently driving this car. This allows us to keep track of them. What's the current drive start time? Like when did the drive start? We want to know so we can time it. We can have payouts match that accordingly. And what's the required end time, right? So we could have some kind of set end time for accountability purposes where it can't, be more than that. And now we'll have some rates, right? So what is the rate of a daily rental, right? So we can set that right now. And let's just say it's 1 ether. So 1 ETH. And so we're going to create two enumerated values, driver entity and drive status. So what I'll do is I will paste that in here. Okay, so And so a driver entity has all of these attributes. They have an owner, an autopilot cab, Uber, and then drive status. So are they driving? Are they turned off? Are they unavailable, etc.? Okay. And now it's just to go over the rest of this. I'll just paste this in and then the code, by the way, is going to be in the video description with all of my documentation, but I just want to talk through it right now. So, the car should be able to communicate its internals to the contract, right? So we'll say, well, what is its internals? In this case, it's just fuel, right? Low fuel, high fuel. What other internals could there be? There could be a LiDAR system. There could be, lights, LEDs, what have you. So that's for the internals, right? So we want a function for that. And so for our smart car, we could say, well, a smart car has all of these different attributes that we can call using the license plate and the value as the parameters. And so how do we set who the owners for the car are? We could do this so many different ways. But for the time being, let's assume that the owners are set by the car signer automatically and they can't be changed. So they're just hard coded in. So we'll just feed it to the set owner's contract, boom, and then it's done. And so when it's time to actually rent the car, here's the function that comes into play. The user calls this function from their mobile device, okay, sending the ETH, like I want to ride. The system generates a PIN number. The user gets the car and unlocks it using that PIN number. And then that's how this works. And you could see all of these actions happen right here. Okay. And so once they're there, they put in their PIN number. Then they could say, well, we require the user to be the one that is authenticated. And if so, return true, the car is then activated. When the car is done renting, then we end that rate daily, right? So that car rental is done. And it's the same thing, except we say, well, that is no longer the driver. distribute the earnings to the owners of the car at the very end, set the new address to not that driver, and then we're done with that. And then comes the functions that both the user doesn't do and the driver doesn't use. It's what the car uses by itself. These are autonomous functions, right? So, someone stopped writing me. Let me transfer the ether for the stipends. Let me trigger the ether transfer. Let me distribute the earnings to the owners. These are all functions that the car does by itself autonomously when it feels necessary, right? Depending on the other conditions. And then we have separated it into functions called by the owners, right? So the owners can say, well, trigger the distributed earnings. We want those earnings. They're in some escrow. Give it to us. Let's withdraw them, etc. And what we can do is we can take this entire thing right here, this entire piece of code, and we could submit it to the Ethereum blockchain, like the test blockchain, by saying going to remix.ethereum.org. We can paste them into this right here, and it's going to just work like that. So anyway, I hope you found this video useful. Definitely check out the code in the video description for more. And yeah, please subscribe for more programming videos. And for now, I gotta go watch Zuckerberg cringe. So thanks for watching.